Hello everyone, my name is Idris Tilman, and I'll be taking you through our project, Interpretable Machine Learning Techniques for Car Health Predictive Monitoring. The data sets we reviewed were two. The first one was automotive vehicles engine health, and you can see its link to the data set. And the second one was engine time to failure, and the dataset is here provided. And the dataset we selected was automotive vehicles engine health dataset. The reason for selecting the automotive vehicles engine health is because there was no missing data and it had no records compared to the engine time to failure. And also the dataset is relevant to the problem we are intending to solve, and the dataset was also clean and with minimal errors. It was also large enough, hence no impact caused by overfitting data. The dataset is also available and easily accessible without any legal and ethical restrictions. The dataset allows scaling, that is to say, it can be increased. And here, my colleague I'll be introducing my colleague, who is past Ben, to take you through.
Well, my name is Brian Responsible. I'm a member of Group 70. I'm going to explain about the exploratory data analysis findings, whereby we used, we went ahead to use Colab to perform this one. We went ahead and explained one, we went ahead and used this this Synbone library, which we imported as the CNS. um, to go ahead and establish these different distributions, whereby we had our engine RPM, which is mostly distributed between 5,500 and 1,000 RPM, which is displayed right here. Then with issues of the loop oil pressure, likewise it is dis distributed between the 2 and the 3 pascals. Remember that is pressure, which is measured in pascals. Then for the issues of fuel pressure, right here, and it is distributed, this line here, is distributed between 4 and 7 pascals. Moving on to the coolant pressure, which is between 1 and 2 pascals. Same, we use this CNS, this plot. We defined our data frame, which we named inside our square brackets, and this is what we established right here. Similar to the loop oil temperature, we are saying that we are telling, okay, it is listed here in our slides that our loop oil temperature is mostly distributed between 75.0 to 77.0 degrees centigrade or Celsius. Yeah, I guess that's it. I'll call upon my second group member, John Masujovin, to pick it up from there.
Yes. So guys, this is John Wasojobe, and as my colleagues have already explained, I've started to continue explaining the correlation part where we want to know the correlation between different features of our dataset. So as you can see, we used the heat map to know the correlation between different features. As you can see the heat map here, all the features, there are 7 features. So you can now know the correlation between each and every feature. So as you can see at the coolant temperature and the engine RPM, they are positively correlated, and the coolant temperature and the loop oil pressure, they are negatively correlated. So each and every feature, we can see its correlation here on this heat map. Now I explained all the findings of our correlation and how each and every feature is correlated with one another. And this is the distribution of our engine, the way the engine condition was distributed, that's the last feature. So we can know how it's distributed when we by using this bar graph. So this bar plot is mainly showing that when it's 0, that's the false part of the engine not being in a good condition, and when it's 1, that is the true part of the engine being in a good condition. So you can see now that the false values are less compared to those that are true. So this is what we are explaining in this slide. Then the last part is the conclusion. And we are concluding as saying the data quality, the data set is high quality since there is no missing values. And the correlation, as we have seen, it's both positive and negative. And if data transformation is needed, we will employ audio data in order to improve the performance of our model. So that's it, guys. Meet next time.